All right, moving on to precision and calculations 2.2. You will need a millimeter ruler. Okay, so let's round each measurement to the nearest tenth of a unit. So tens are, come on, that decimal. So 4 rounds down, so it's 5.8. 8 rounds up, so it's 2.7. 5 rounds up, so it's 0.5. The number of significant digits in a measurement shows how precise the measurement is. You need to know about significant digits when you multiply or divide measurements. So significant digits aren't as talked about or as important anymore. It wasn't when you're dealing with specifics and precision. I remember when I took it in physics, it was important, but even now in physics, it's not as important as it used to be, but it's good to know what it is. So significant digit is just digits that are known with certainty. So this is 3 significant digits because there's 3 numbers that matter. This one is 3 as well. We'll look into it. So identifying significant digits. Non-zero digits in all numbers. All non-zero digits are significant. For example, all those are. Zeros in decimals. Zeros in decimals are significant only if they appear to the right of the first. So that's why I said 3 here are. This 0 doesn't count. But if there's a 0 in the middle of something and to the right of the decimal, they all count. So it's 1, 2, 3, 4, 5. So that's significant 5 digits. This one as well, that's 4. 4 and 4. They each have 4 because these two don't matter. And zeros in whole numbers. Zeros in whole numbers are significant only if they appear between non-zero digits. So that one matters, that one matters. So they both have 3. Zeros at the end are ambiguous. For example, 1300, it only has 2. So what makes a digit significant? Think about metric conversions. 2,000 mils is 2 liters or 0.002 kiloliters. The 2 is significant because you need it to express the measurement in any unit. The zeros are not significant because they change depending on which unit you use. Just so you know. So how can you identify which measurements match each of these? Okay, so one significant digit is this one. Let me see if I can do this without the answer key. 2 would be this one. 3 would be that one. 4 would be that one. And 5 would be that one. Where does it make sense that the results of the measurement calculations cannot be more than precise than the measurements used? Because you can't just make up numbers. Anyway, those are significant digits. Not super important that you know it. I don't think it will show up on your exam to any degree. Maybe for like a couple questions or something, but. All right, example 1. We have Jen and Max measured a rectangular room. They wanted to know the length of the baseboard. How should we report the length of the baseboard? Jen's measurement room is this and this. Max measured the door at this. Solution. How much baseboards do Jen and Max need? Length of the baseboard is the perimeter of the room minus the door width. Perimeter is the length plus the width, which is 5.241. Wow. Length plus width, 5.241 plus 3.845 minus 0.76. Your answer, 17.412. How should they report the length? The least precise measurement has 2 decimal places. This one, it just has 2. So that means that the length of the baseboard should be reported to the nearest hundredth, because that goes to a hundredth of a meter. So they should round up because they won't buy enough baseboard if they round down. They won't buy enough baseboard if they round down. They need 17.42. So even though that was a 2, they rounded that 1 up to a 2 so that they could cover that. Example 2. Dan bored a cylindrical hole through a piece of aluminum that was 13.1 millimeters thick. The radius of the hole is 6 millimeters. How much material did he remove? We're looking for volume. Volume is pi r squared h. Oh, excuse me. So we're looking for a radius of 6, a height of 34.1. So 6 squared is 36 times 34.1. That's, so the 2's gone now. It's inside. That times that is 3856.619. The known precision of the measurements is 3 decimal digits, so the volume should be reported to 3. Dan removed. Well, we're going to remove all of this junk then and just report 3, 8, and we're going to round it to 6 millimeters cubed of material. Again, significant digits aren't super important, just something that you should know exists. There's a little bit of practice here that we'll go through. How many significant digits are in each measurement? So for the practice, I'll do a couple here. So this one is 3, this one is 2, this one is 1. You guys do the others. Measure and label the side lengths. What is the perimeter of each shape? So measure these with a ruler and calculate the perimeter. The perimeter is equal to side plus side plus side dot dot dot, however many sides you have. And then just give me the answer. 3, calculate, record each result to the correct degree of precision. That plus that is 9.3. We're leaving it as 9.3. This plus this is 7.97. We're going to leave it to do 2 decimal places because we don't have the third one. This minus this, we get 16.2. Again, leave it to this decimal place because we don't have hundreds in both. That divided by that will be 6.8. Again, this is 2 significant digits. This is 3, so our answer has to be 2. And then this divided by that is 12.2. And we are leaving it in 3 significant digits with the tens. Pi times this is 4.7. Again, we're leaving it in that decimal place. Let's see, 4. Kendra lives in Dawson. She is making a pendant. She wants to put silver wire on the necklace. She has measured the diameter with, so your diameter is that. What's the length of wire that she has to cut? So the circumference is pi times the diameter. So pi times this is going to give you your circumference. So just tell me the answer there. Okay. So that one's for you. Number 5, the inner radius of a can is that. The inner height of the can is that. How many milliliters of water can you hold? Well, we're given the volume here, and we're given the conversion here. So I'll do 5. So we have volume equals pi times, so area was pi times 5.2 squared times pi, so pi r squared. And then the height was 18.5. We get 1,571.500. So we're gonna significant digit this to 3 significant figures, which is 1570 mils of water. Good. 6, you guys do it. Measure the length and width of a door. What is the area of the door? Measure a door. What's the area of the door? Area is length times width. Compare your answer for part A with the answer that come with your classmates. Are your answers the same? Don't worry about that one. 7. HVAC mechanics build and install transition elbows to connect different sized ducts. How long is the diagonal side of X of the transitional elbow? Okay, to do this, you're going to have to 20 minus 15 will give you this little section here, which is 5. And 25.0, 5.0. So you know Pythagoras is a squared plus b squared equals c squared. Figure out what that length is. It should be more than 25, your answers. So a squared plus b squared equals c squared. Put in those two values there and there. You'll get your c squared. Remember to square root this side, and you'll get your answer. It'll be greater than 25. So number 8, Caden is building a straight concrete walkway. The walkway will be 8 meters long and 0.95 meters wide and 12 centimeters deep. How many cubic meters of concrete does he need? We're given the formula here. Volume equals length times width times height. So all you have to do is times these 3 numbers together. Volume equals 12 times 8.0 times 0.95. What do we get? And make sure that you round your answer to 2 significant figures. Good. That's that section. For the next section, solving a measurement puzzle, you'll not have to do that. So the next video will actually be on 2.4 precision and accuracy. Thanks for watching.